Hi everyone, welcome back to Dr. RCM Academy. So, in this session, we will be talking about work done in moving a point charge. We all know there is a gravitational force, and whenever there is an object and this object, we can see there is a gravity which pulls towards the earth. Any object which is left free in air, this will automatically falls on the surface of the earth. This is due to gravitational force. So, now whenever we need to move some object towards the gravitational surface, we need not to do any work. The field itself does the work to bring this object onto the surface because of the gravitational force. Suppose if we need to bring this object back to the position in the air, or we need to bring the object against the electric field, we have to do some work. So, therefore, in general, I can specify work is done if we need to move an object opposite to the field, because this is the gravitational field and we are moving against the electric field or the gravitational field, and hence we need to do some work. Same concept, we will be applying for the point charge or any electric charge. So, what is the work done in moving a charge in an electric field? So, let me assume there is a charge q 1, which is some positive charge I have assumed, and whenever there is a charge, there will be field around that. And if I try to bring some other charge into this region, and if this is also positive charge, so we know that it repels. So, which means this field or the force lines, because of this charge q, will push the other charge away. So, when work is said to be done when the charge is moved against the field, suppose if the charge test charge is moved against the field, now automatically whenever the charge positive charge is placed here, this will move away from the q 1. If you need to bring this charge towards the charge q 1, definitely we need to do some work. That is what work is said to be done when the charge is moved against the electric field. Now, according to definition of electric field intensity, we have defined in the previous videos what is electric field intensity. So, electric field intensity is force per charge, test charge. So, E is equals to vector E is equals to vector F divided by q t. In other words, I can write the above equation as vector F is equals to E dot q t. So, electric field into the test charge. So, this is the force that is applied on this charge due to charge q 1. This is the force applied on test charge due to q 1, and this is moving a small distance of d l, okay, which is away from the charge q 1. So, therefore, the component of the force, it is along the direction of A L. Therefore, I can write the component of force, that is F L, can be written as F, the force on q t due to q 1, into unit vector A L. This is along the direction of A L. Now, what is F L? So, from equation 1, I can substitute F as F is equals to E into q t. So, I have substituted. So, in place of F, it is E into q t into unit vector A L. I will write it as it is. This is the force component applied on q t due to charge q 1. So, this force is responsible in moving a charge q t for a distance of d l in the direction of field, because the work is done by the field itself, we are not doing any work. Now, if we need to bring the charge against the field, we know that we need to do some work. So, that is the work done on moving a charge in the electric field against the electric field. So, that should be the amount of force that you apply should be equals to the force that has been exerted on the q t due to charge q 1. but this negative sign indicates we are moving against the field. Force applied. So, to bring back the charge qt to q1, so we need to bring it in the opposite direction. Therefore, it is minus q into E dot A L. This negative sign indicates we are moving against the electric field. Therefore, the work, this is the force applied, but we need what is the amount of work done on moving a charge q or qt against the field, and that will be equals to dw is equals to minus FL into dl. So, what is FL is, so the force that is exerted on the charge qt, which in the previous equation we got it as q into E into vector AL, and dl I will write it as it is. This is the differential work done in moving a charge against the electric field, that is minus. Therefore, so I can write dl into unit vector as vector dl. So, it is minus q into electric field intensity dotted with vector dl. So, this is the differential work done. So, if I want to calculate, so what is the total work done in moving from one point to another point? So, I need to integrate throughout the limits from initial position to final position. So, what is the differential work? Suppose in this case, so in general I can write, so it is dw. So, we already found it is minus q into E dot dl. So, since minus q is constant, I will bring it outside. So, it is integral of initial to final E dot dl. This is the work done in moving a charge q against the electric field. So, here the charge is assumed to be at rest both at initial and final positions. These are the assumptions that we need to make, and so path must be specified. So, from where to where and in which path it has to be moved. And here you can observe w is equals to minus. So, the negative sign indicates that we are moving against the field, and suppose if this is positive, which means that work is done by the force and we need not to, external source need not to do any work to move a charge. So, negative indicates work is done by the external source, okay, that is against the electric field. If this is positive, then work is done by the field itself and external source need not to do any work. So, this is about total work done in moving a charge against the field. So, thank you for watching the video. So, if you are not subscribed, kindly subscribe to the channel, and you can share and like the video, and if any relevant video is required, so kindly put it in the chat box. Thank you.